Our next presentation is going to be remote, and it is Matthew Wilder, a senior engineer at TELUS, who is speaking us from Vancouver today. The title is IP Inventory Management APIs. This is Matthew's third time presenting at NANOG, if you count his first submitted talk, which was delivered by his colleague. I remember that one. Matthew's first talk was called Deploying IPv6 at Scale at an ISP, NANOG 65 in Montreal, which is cold, delivered by Clinton Work. His more recent time on stage was also in Montreal for NANOG 85, where he joined the panel discussion of the World IPv6 Reunion. Welcome back to NANOG. Matthew, it's a pleasure to have you with us today. Can we bring in the remote?
Howdy. All right, thanks very much for the intro, Alex. I'm very happy to be presenting here about IP inventory APIs. As mentioned by Alex, the previous instances of my speeches at NANOG have been around IPv6. So kind of glad to take this, this opportunity to talk about a different aspect of networking. And actually, I want to give credit to a couple of program committee members. So Michael Voidy was initially the one helping me prepare this. My hope was to get this to you at NANOG 92 in Toronto. However, my schedule was just not cooperative and I didn't get it ready in time. But actually, I was intercepted in Toronto by Adair. Adair Thaxton approached me and said, hey, did you know in Atlanta for NANOG 93, we're looking at doing a real focus around automation. So I've been very pleased as I've heard the talks for NANOG 93, and I think this really fits in. So I'm very glad Adair approached me and helped me get this ready. So thank you. All right, so what I'll be talking about today. Before actually getting into the APIs, I want to talk about framing the IP inventory challenge. And then I'll do a little bit of audience survey participation. So I've got two surveys, sort of one up front, just to get a sense of where everyone's at in their automation journey and IP inventory within their enterprises. Then I'll get into the meat of it, which is the IP inventory APIs themselves. And then talking about how do we differentiate different pools of IP addresses. I'll talk about some implementation considerations, which likely you will encounter if you go down this road yourself. I'll talk about some example use cases, and then I'll show a demonstration. I'll put demonstration here in air quotes because this is just screen caps, but you can trust me in this one. These were really executed via Postman, etc. And then again, audience survey part 2, again, to get a sense of where you're at. And I'm really looking forward to hearing those details. Obviously, I wish I was with you in the room to see that feedback. So I will rely upon someone in the program committee, hopefully to jot down the responses that we get for those surveys. And then I'll talk about what's next with the APIs. What do we have in mind to evolve those further? So without further ado, I'd like to talk about framing the IP inventory challenge. So at the heart of this, I've got the principle of centralized inventory, and this may or may not be a principle within your enterprise, but here's the array of considerations or possible principles, and maybe there are more within your organization, but for us, we are a large ISP with many different service offerings, many different networks, our own enterprise network, of course, and in order to coordinate effectively and realize opportunities around automation, it is our ambition to more or less centralize the inventory of IP addresses and other inventory functions as well. And we are relatively successful in that. We do have a couple of one-offs which are not baked into our primary IP inventory or IPAM system. So that's just one thing to kind of frame this challenge here, but there are others as well. So of course, records accuracy is quite crucial. I heard the panel this morning talking about source of truth. I've got a lot I could say about that as well. And I think the idea of intention is probably the best. And when it comes to IP addresses, the idea of declaring that this is the reality of how an IP address is used is a fiction, because I can't control what someone on the other end of the network is doing. They may be able to configure an IP through static routes, or statically assign it to a device, or put it through a firewall rule. There are a lot of things that could happen that don't necessarily become accounted for in the IPAM, but that is an ambition. Automation ready, of course, that's the purpose of APIs, is to sort of create mechanisms to invoke assignment and changes to these inventory systems. So that is the intention. RIR registration. So I don't know about all the RIRs, but I know that within the ARIN region, there are policies that say if you're reassigning subnets to customers, you need to register them within the registry. So that's another consideration. Maybe you want to automate that as well. And then also a newer feature of many of the operations we see online require some kind of geolocation. And of course, there's now an RFC to help with that. So RFC 8805 allows network operators to publish the geofeeds declaring where an IP address is being used. And so you may want to automate that as well. So all these different pieces are kind of coming together. And I'll be talking about that a little bit more as we go through the presentation. But let's take a pause here for audience survey part 1. The question here is, does your organization use mainly one single IP inventory system or multiple? So option 1, show of hands, if your organization primarily uses a single IP inventory system. Raise them just for a few seconds, and hopefully someone's doing a count. Okay, and put them down. Option 2, multiple IP inventory systems. Show of hands, whose organization is using multiple IP inventory systems that are discrete and don't necessarily speak to one another. All right, hands down. Thank you. I'm not looking for exact counts, just, tens, how many tens of people in each category, etc. All right, now into it. Introducing the APIs. So here's a very high-level inter-system framework that ultimately we're trying to introduce with these APIs within our organization, and we've already realized this to a certain degree. So I'll start in the middle. So we've got this API gateway, and I'm sure that any of your orgs that are trying to do large-scale automation and lots of APIs with different systems, likely you have some kind of mediation there. So we have an API gateway that mediates these API calls. Above that, we have many different systems which are trying to access IP inventory for either assignment of resources or discovery, enrichment, etc. And then below that, of course, we have the actual IP inventory or IPAM system that's primarily today has been used through GUI. So, users can get to that interface and manipulate the data and the inventory. But also now we have these APIs which allow that manipulation to occur. And then off to the right, we have two other systems, RIR registrations, and then geofeed publishing, as mentioned before. So those are kind of outflowing bits that come from potentially from the assignments that are made through the API calls. Just good to kind of have that high level idea of how does this flow, how does the data flow, and automate end-to-end assignment of resources, and then the outflowing registrations and geofeed. All right. So now to actually talk about the APIs that we're using for IP inventory, and there may be others that you are aware of or are using. It may be homegrown, maybe open source with other formats, but during the opening keynote, there was a question from an audience member who asked about TM Forum. Where does TM Forum fit in this? And it happens that we are using TM Forum APIs here. So these are open APIs. The ones I'll draw your attention to today are TMF639 and TMF685. So first, TMF639 is resource inventory management. The intent of this API is to query and manipulate IP inventory. The specific APIs within that include get details. So let's say you have an IP address and you want to discover what is that IP address used for. This can invoke a call to learn from the IP inventory what are the metadata around that API or that IP address rather. The second is modify. So let's say you have an IP resource, could be a prefix, range, or IP address, and you want to say this was assigned to this loopback interface. You can update it to show that it's available now because it's no longer used. So that type of an update could occur through that. The other is where we get into the actual assignment of a new resource, and this is a little bit more complex. And as much as possible, we've designed our instance of this API to be generic, and we don't have to worry about what are the specific resources necessarily. And so we keep the fields generic, and you'll see that in a second. But effectively, this intent is to acquire resources. So an upstream system might call the API and say, give me a resource or IP prefix from a given pool with these parameters. And that's the assign IP prefix. We'll go into the detail in just a second here. The other is, there's two more. So one is assign IP address from a pool. So again, the intent there is another generic way to get an IP address so that all kinds of capacity management can be going on behind the scenes, and you don't have to worry about updating this API payload to say, here's the new range. We can keep that generic through this method. And then lastly, there is a more specific and attached API payload where you actually do specify, give me an IP address from that prefix, that subnet. Okay. Yeah, let's start off with the most broadly used and most generic one, which is kind of elegant here. So the API call contains, I'll say, two types of data. The first is selection criteria. In the selection criteria, we're saying, essentially, I want a range that has this prefix length, or CIDR. It belongs to this IP pool, and IP pool is a term of art, but it could be container in your IP inventory. Just a generic grouping of IP resources. And then also, what is the region? So where is this geographically? And if you're operating a large network, whether that's international or even nationally, in the case of Canada, we have coast to coast, we have enough latency east to west that we do worry about region, and we do allocate IPs regionally. And then also address purpose. And address purpose is just a label to distinguish between different particular purposes within a given pool. Not super critical that you follow this exact model. Of course, if your data model is different, you would just implement the API according to your data model. So these are the selection criteria. And just to draw your attention over to the right, what's happening here is the IP inventory system, when it receives the API call, it's going to look for a matching set of resources. So it's going to say, can I find an available resource that has that specified prefix length belonging to that IP pool in that region, set aside for that address purpose? If it does find one of those, it's then going to apply the descriptive labels that were sent through the API payload. So that includes some kind of description, additional details. It might even include a customer record, optionally in our case, but again, it goes back to what your data model is. And so if there is an available matching resource, the inventory system marks that from whatever status it was, unavailable, to now assigned. And then it also applies those descriptive labels and matches it to the customer record, and then it replies through the API call with the resource that has been assigned. If there are no matching available resources, it will simply respond and say, no resources found, no IP addresses for you. The other one I want to draw your attention to is assign IP address from IP range. This is a much simpler selection criteria, as you can imagine. So you're basically saying, give me an IP address from that particular IP range or subnet. And of course, the inventory system will look up are there any available IP addresses within that specified IP range, if I can find that matching IP range. And then if there is one, it will apply those descriptive labels, set the status to assigned, and pass back that IP address that has been assigned in response to the API call. All very nice. So now we get into the implementation considerations to some degree is how do we, in an IP inventory or an IPAM, differentiate different pools of IP addresses? At a very, very high level, you have differences and important distinctions between IPv4 and IPv6, for instance. You also might want to consider private IP versus globally unique IP. Again, as mentioned in our case, you may want to associate IP addresses, or you may already associate IP addresses with one region versus another. And there's also pre-existing configurations in many different domains. It could be routing, could be firewalls, ACL rules, and so on down the line. And hopefully your IPAM, IP inventory system can reflect that to some degree to indicate to a user, to other systems, how is this IP address used today, and keep those logically contained, especially as we go down the journey of automation. You lose the human intervention that could occur to understand those details. So more and more you want to encode that into your IP inventory, into your IPAM. All right, so other implementation considerations. Let's start with the fun one. So IPv6. I don't know that I'll ever give an analog talk that doesn't talk about IPv6. So here it is. Here's the IPv6 bit for today. Be careful with IPv6 address formats. And did you know there's actually an RFC about that? I learned that when I was putting this together. So RFC 4291 talks about all the different legal representations of the same prefix. So here's 3 different representations, all perfectly valid. They are very clear. However, they are not consistent, of course. And so one thing we encountered, and I expect you would as well, going down this journey is different vendors, different software will display possibly different correct legal representations of the same resources. And that can cause problems, of course. So if you're saying from that API call up above, hey, I want to update this resource to that status. Well, it turns out if they're not matching, you may have a problem because your systems may be looking for a textual match, and the string, of course, won't match if they're not using the same format. There is another RFC describing recommendation for IPv6 address text representation. So RFC 5952 could be of use to you here. And effectively what we've done is within our API gateway, we have a translation function which detects when an IPv6 range has been sent. And then it basically adapts that text string into one single version of the legal representations according to RFC 5952. So there are workarounds. Just want to draw attention to this piece. All right, considerations. Another piece of where you might want to consider IPv4 and IPv6 and how they interact or are different and distinct. I'll work from the top down, sort of a hierarchical model here of different types of IP. So we have on the left here, we have IPv4, of which there are different address families. There, of course, are globally unique IPv4 addresses you would get from the RIR system. And then there are private, which are typically defined through IETF standards. Probably the 2 most prevalent you'll see in your networks are RFC 1918 and RFC 6598. So these are the different address families most commonly seen. And then there's IPv6. There's all this globally unique IPv6 RIR space, which is very sparsely assigned so far, and there's lots of it available, and that's its greatest feature, and that's why I've got it in green here. Private IPv6 or ULA, at least within our network, we tend not to use it because there's just so much globally unique available. We want to not have to worry about merging networks and extranet requirements, all those things that could arise. So why I've got the rest in red and just globally unique IPv6 in green is the extensibility and scalability feature of IPv6 is very, very attractive. As we automate more and more, we want to see more and more infrastructure and services rely upon IPv6 so that we can scale and not have to worry as much about capacity management, which is obviously quite constrained in any of these other categories, including the private ones. So any large scale network, the RFC 1918 space and RFC 6598 space will only get you so far. So IPv6 is where we're looking. Just to drive that point home, again, we are looking more and more at IPv6 enabled networks to allow simplicity, automation, and scalability. I'll give you a second so you can take a picture and share it with your colleagues. All right, some example use cases. So here's a case example one where we're talking about service IPs. So the intention here with this API call is I want you to assign me an IPv6 range. And I know that this is a bit of an eye chart, more than a bit of an eye chart, but hopefully importantly, you can see the before and after that there is a difference. These slides are available for download if you want to see in more detail. But let me talk you through what's happening here. On the left here, we've got the API parameters that have been passed. So again, the selective criteria saying I want a prefix length of 48 in the IP pool called service X, the region being Alberta and specifically Calgary, Alberta, and an address purpose of static. And then here are the customer details. Customer N is the name of the customer. The description is Nanog Demo 1 and details, this is order N. So we've executed this through Postman. And the result is, you can see written into the resulting IP inventory slide there, there is now a third assignment where before there were only two. And so now this resulting range that was assigned was also passed back through the API. So the upstream system is getting all this information. Second use case I'll give you is infrastructure IPs. So let's say this is, give me an IP address from this parent range. So maybe it's a particular loopback range or something like that. So we're saying, here's the parent range, 198.51.100.0/24. A description is router X, details is interface Y, and the resulting assignment is 198.51.100.2/32. And you can see the result in the inventory system there. Another use case you might want to use this for is not actually for assignment, but maybe for network troubleshooting. This could also be used for enrichment for your data in terms of your network discovery and different automation efforts you might have that could benefit from knowing more about your IP inventory. So the intention here is I want to discover the usage of the IP address 192.168.255.2. And the API call goes ahead. And what comes back to the calling system is the descriptions, these metadata, descriptions saying router X, details saying interface Y, and then these other details, IP pool, region, and purpose. Okay, now time for the air quotes demo. Here is a sequence. So part one of this demo, what I've done here is set up an inventory. So I've got all these /48s set up within an IP pool. So they're associated, you can see, with an IP pool called ORAN. This is a subtle nod to Open RAN, which many mobile operators are deploying right now. We also have the region of Ontario here, ON, and then address purpose of infrastructure. And you can see all these resources currently are in a status of unassigned and don't have any association with customer, description, or details. Here is a snippet of the Postman call. So the API call you'll see here has reference to that IP pool of ORAN, has reference to the prefix length of 48, has reference to that infrastructure address purpose, the region of Ontario, and it then also has descriptors to apply, ORAN Site 1, and so on. So after executing the postman call, here's what we see in the inventory. So we see that indeed this was assigned, and we got the customer associated, as well as the description and details applied here. And of course, that IP range assigned was passed back to the API call. All right, as we get toward the end here, it's time for audience survey part 2. Does your organization make use of APIs for IP inventory management? So show of hands for option 1, yes. All right, hands down. And then option 2, no, or at least not yet. Show of hands. Okay. I'm curious to hear what the results will be here. What's next? So the future additional APIs planned involve the setup of IP inventory, including allocation, so allocating resources to a pool, splitting it up into additional subranges, and then capacity and availability reporting. Currently, we're doing capacity management through our GUI. Effectively, we're looking at exports to track how are we looking for each of the set of criteria that might be called upon for resources, and typical linear projections and forecasting to say here's more capacity, but completely manual now, although looking at future APIs to assist with that. So there it is. IP inventory APIs coming soon to a network near you. And now I'd like to entertain questions and comments.
Oh, I think Tim got to the mic before Mike, so you're up.
Hi, Tim Novacek, All Points Broadband. A little bit of a question about implementation. I see your API gateway that you had up there, and I'm kind of curious how that works. We use Infoblocks for API and have written calls against, or for IPAM, and have written API calls against that in our provisioning system. And wondering if there's like a commercial product you use, or if this is all in-house to implement all the TM forum stuff.
Yeah, so a lot of the development's in-house for sure. We use, for our API gateway, we use Kong. I think there are others available as well, but in our case, we have a large set of APIs across many different systems. So the API gateway effectively mediates those API calls, makes it simpler to onboard for upstream systems, not having to get authentication to every single API they might call. That's really the purpose of the API gateway. But yeah, there is certainly an element of development of these APIs based on the TM forum specifications, but tailored to our data model, to our systems.
That's Kong, like King Kong, or I'm not familiar with this product.
Yeah, like King Kong, Kong. Actually, I think it's like a gorilla is the icon for it.
Okay, thank you.
Cool. Thanks, Tim. Mr. Boydie, anything online?
Nothing online, but I wanted to let Matt know that I posted the results of his 2 surveys in the Q&A
Awesome.
chat.
Thank you.
Okay. Anything else? Going once, going twice, going thrice. Thank you very much.